Afternoon, everyone. I'd like to bring to the stage, well, he's already on it, Wayne Phillips, and he's going to be talking about the art of cyber war and rules of machine speed engagement. Please make him feel welcome.
Woo! That was me. Thanks. My name is Wayne Phillips. I'm the field CTO for SentinelOne, and I've been with the company for 4 years. Before that, I started off as a sysadmin doing security for normal enterprise customers, moved into system integration, and then worked into the mobile space. So we had to build and manage products that secured mobile devices. And as you know, physical security is very difficult. So it was an incredible sort of journey of, right, I need to learn security really quickly because securing physical devices is almost impossible. And then I worked as a product manager and a CTO. So then we had to build something that actually supported these mobile devices. And we did that in our own data center. We did data center to virtual, we did virtual to cloud management, and then we did cloud to cloud migration. So security, mobile, and cloud is kind of, it seems to be my journey. And unfortunately, that's where we are in 2024, is we need to secure mobile devices and cloud, and security is to the fore. So it was kind of a good runway into security, modern day security. So today I was going to talk about the art of cyber war. We do a lot of cyber ranges. Obviously, I can't talk about some of the stuff, but some of the artifacts that come out of running a range or dealing with threat ops challenge with military or military industrial people. It's funny, it looks like a large-scale MSSP, and it also looks like a large enterprise, right? So, or it looks like the early stages of a breach. So there's a lot of tangible between military exercises and actually running an MSSP. It's quite similar, which is worrying. So what are the SOC challenges when you're trying to defend your organization, but also other people's organizations? So queue velocity. So this is generally when, if someone's trying to breach you, they will just absolutely flood the SOC with stuff, right? So you miss the smoking gun in the noise. So you need to be able to basically defend at speed and triage almost instantaneously. And if you're a big SOC or a large enterprise, then this would be just a general day in a SOC, right? You get long queues of alerts, and then you have to work out whether they're true positives or false positives, and you have to do thousands of investigations. Also, the complexity of the systems. I mentioned cloud. We're all doing cloud transformation, or you're already in the cloud. And new technologies come out like Kubernetes and Docker containers and things like that. So we all have to know and understand these new technologies and how to secure them, and understand how these things are attacked. So it's getting complex, or getting more complex, which means you don't have enough time to do proactive threat hunting. And we've got we know we've got a talent shortage. It's not we've got a shortage of people that want to do cyber, because lots of people want to do that, but we've got a shortage of people that are very good at it. At that sort of third level or architecture side. Right, so what do you need to do? So a normal SOC, generally it's based on some sort of endpoint protection. We've started to get quite good at endpoint protection, so the attackers have moved into the identity space and now attacking us as social engineering attacks and things like that. Old Active Directory that's been sitting around unmanaged for a while, so people are attacking that. So you need to have some sort of identity protection, or ITDR, identity threat detection and response. Exposures, so the normal CVEs, that could be firewall rules, but also CVSs, CVEs, that kind of thing. And apply deception if you can. And today we're moving into the XDR space, so extended detection and response. So it's not only endpoint and identity, you have to kind of bring in IDP data, firewalls, WAFs, things like that. And cloud is to the fore, so you need to have a lot of cloud data. And having that data in one place helps the SOC analyst, because if you're going from a SIEM and then you're finding an incident and then you have to go to another console to triage and then you have to go to another console, it's really slow. And again, it takes time. You can't deal with the velocity of incidents that are coming in and you get burnt out because you're jumping between consoles and human error comes in. So you need to apply some sort of machine learning or AI. Now I'll try to distinguish the actual types because I've been to a few sessions and all of the terms are used synonymously and it's quite confusing because people have been using them out of context. It's quite funny to listen to, but if it's a static AI, I'll call it a static AI and an ML and an AI. We'll try and go through that. This is kind of a streamlined security analyst SOC workflow that you kind of need to do from one place. So you need tooling to do this from one place. So you normally start at an endpoint. Let's just go, could start anywhere here, but let's just start at an endpoint where you start to see an incident, maybe an atomic entry, and then you try and work out, where did that come from? Where was it going? What was the intent? And then you have a look at the machine. And then you start to go, okay, what user was involved? How many users were involved? Do they have admin rights? What was the behavior of that user earlier in the day? Is this new? Were they given admin privileges recently? Are they part of backup admins? And do they have access to cloud assets? Okay, well that's a backup admin. They actually have access to cloud stuff. Have they been accessing the cloud? And then you can see this playing out. So you start to follow the bouncing ball, and you can go from an endpoint to cloud misconfiguration in about 4 steps. So being able to track threat paths is important. Whether you do that manually or whether you visualize that, it's incredibly important. And especially if you're dealing with large-scale SOCs or military exercises, that's what they'll do, is they'll move laterally through things to try and get to your critical assets. So, what's that? Any ideas? What type of bear? It's a fancy bear. It's my first dad joke of the day. So also known as APT28, right? So you can have IOCs for fancy bear, right? They're listed everywhere, but it's quite easy to change those IOCs, change the hashes, change the IP addresses, and then it's just a normal bear, right? But you still need to detect that. So the day of virus definitions or looking for patterns, are gone, right? So you need to have the machines to do this looking for you. So how do you know what that is, right? It's because you were trained. You went to school and you were taught what a bear was, right? So some of you might know what that is. Some of you might think it's a bear or a black bear. Some of you might know what type of bear, whether it's male or female. Anyone know? Anyway. And you do that by looking at facets, right? So this is the basis of static AI. So you would look at facets. Has it got ears? Is it nostrils open? Are they closed? Are the eyes rounded? And what shape the tongue is. So it's a Formosan bear cub, right? Again, we would guess, but a machine would know, right? So it makes it easy. So you can do the same thing for almost any picture. You can work that out. And then what you can start to do is apply numbers to that. And this is how static AI works. So I do go to a lot of conferences, and generally they don't teach you how these things work so that you can assess whether the product you're buying is fit for purpose, right? So this is how static AI models work. And then they'll build a feature vector, right? So the model will say, okay, it'll scan petabytes and petabytes of data. So you'll need a product that does scan a ton of data to make models for you. And if you can make the distinction quite simple, like is it malicious, is it suspicious, is it benign, or is it unknown, then the model won't hallucinate, right? So if you're very discreet with what you use the technology for, then you can do things like that, right? You can start to group things together and you'll know what they are. Yeah, you can be very specific, the types, the sex of the animal. You can treat files the same way, right? So files have many more facets. So we do the same thing or the same technique to files, and then we map them on a 3D vector, right? It's multi-vectored, but this is a 3D description. And then you can see ransomware fits in that, malware's there, Trojans are there, and hopefully you see that Microsoft Office, Windows, and malware are all kind of grouped quite closely together. Right, so the machine said no. What do you do now? The model said it's bad. As an incident responder, what do? You need to kind of analyze that, right? You need to your job's on the line. Is it true? Is it false positive? I'm new to this, and how do you work that out? And traditionally, that's the problem with static AI. The machine said no, and then you have to determine whether it was true or not. So was it a true positive? Is this a targeted attack? Why was it bad? So you obviously call in Jeff from Digital Forensics to come in and pull Ghidra and rip the file apart. No, you don't do that because it's really time consuming, right? And you can't do that if you're under attack. So there are new terms called mixture of experts, right? So these are generative AI terms. If you haven't come across them, Google them, have a look. So basically what this is when you're building ML models, you can bring in bias, right? So to stop bias happening, you can build multiple models and then have an election. So you can have 3 or 4 models and then go, okay, well, 3 out of the 4 models say it was bad. So having a mixture of experts, makes it more accurate when it comes up with that assessment. And not only mixture of experts, then mixture of models, right? So there's generative AI, there's behavioral AI, there's static AI, there's predictive AI, there's a lot of AI, right? There's static analysis, right? So you need to look at products and understand what a static AI is, behavioral AI, and what large language models are, right? And what they do is things like this, right? So you'll pull a file apart and then the model will check the file and will give you human feedback. So I've just, there's a lot of words on there, but it'll come up. So anomalous number of operations to suspend execution, referring to process operations and random number generations. So as a SOC analyst, you look at those 3 and go, right, well, it's accessing a lot of files and there's number generation involved, so maybe it's encrypting files, right? So maybe this, if it ran, would encrypt files. So as a SOC analyst, you go, right, well, I'm going to escalate that because I think this is ransomware or a precursor to it. So it needs to give you information. So you need to have models to analyze the response to other models. And the same with behavioral, right? So this process ran information discovery, or this system information gathered more information from the endpoint and a persistence mechanism was applied, right? And as a SOC analyst, you go, okay, right, I understand what this is, and I can escalate, or I can just say this is a true positive. So there's a number of technologies that you need to build into a SOC, mostly based on artificial intelligence, which is trying to get the system to act like humans, but then machine learning, right? Machine learning is a class that tries to mimic human behavior, and then static AI is basically built on a large amount of data. So you train the systems on a large amount of data, and it makes determinations based on that. Generative AI, as it says in the term, it actually generates things. So if you're confused on the different terms, generative AI generates things. So you ask it a question and it will generate a poem or a receipt, or it will generate a threat hunting query. So the generative AI will generate things for you. And then you have large language models, and that's just a massive amount of data that's based on the internet, right? So it's how to process natural language. But when you're looking at large language models, you need specific types, right? And I'll try and explain why. So the retrieval augmented generation AI, right? I know it's halfway through day 3. It is quite technical, but it is important to use retrieval augmented generative AI. I heard someone yesterday say, oh, well, we'll just add that data to the model and we'll rebuild the model and carry on. It takes 10 days to rebuild an LLM. It costs $10 million US. It's not something you can rebuild and it's available tomorrow. So the best way to think about retrieval augmented AI, generative AI, is looking at the matrix. Do you remember when Tank, if anyone hasn't seen the movie, this isn't going to make any sense, but Tank taught Neo how to do things from disks. So Tank plugged a tape drive in and taught Neo how to do combat training. And then he was going to learn jiu-jitsu. And now he knows kung fu. This is how generative AI works. This is how RAG model generative AI works. So what happens is you have an orchestrator. And that orchestrator knows about language, but it doesn't know what a lol bin is, right? And as lol bins are updated, or an ATP comes up with a new IOC, you can't put that into your LLM and rebuild it, because it will take 10 days to come out. So what you need to do is you need to attach it to knowledge bases, right? And a knowledge base is just a list of static data. So when you ask it, can you bring me back any indicators of wizard spider that relate to lol bins? It doesn't know what wizard spider is, and it doesn't know what a lol bin is, or it might not. So it needs to go to a knowledge base and pull that back. So it needs to have knowledge bases of threat indicators, the MITRE ATT&CK framework, and just standard terms. So when you're buying or looking at technology, it needs to have a RAG model so that it can be updated live. So you don't have to wait for the LLM to be rebuilt. It brings that data in at that time. When the data comes back, you need a statistical model. Right? What in this data should I be looking at next? And this is the fundamentals of a RAG model. Again, they're quite technical, but this is focused on LLMs or large language models. So you need a query translator. You need to be able to check whether that's been run before and has a cache, so it might speed up the transaction. And then you can, that question is in English, and then it must translate that into some sort of threat hunting query and come back to you. And you may, in the query, say, can you summarize this in a table? Or can you give me this in a graph? And you need something to produce that for you. And I suggested, once the response comes back, it will then give you a suggested next question. Okay, well, here's 45 general responses, or 8,000 general responses. There's 4 at the bottom that you should probably look. Have you tried searching for those specifically? And you can just click on that and it will search, right? That's another model. So it needs to have not just a ChatGPT style one model that does everything, because they hallucinate all the time. You need to have very discrete models that do very specific things so they don't hallucinate, and you can swap them out if they stop working. So generative AI hunting. So why is that important? It empowers every SOC analyst. To get from a junior SOC analyst to a level 3 is really quick if you start using generative AI. And by the way, this is I work for SentinelOne. This is available today. I've heard a lot of people say, oh, it's available for early access, it's available for beta, it's available today. So we sell this now, right? So you can have generative AI threat hunting across XDR data today. So as customers start using this, their level 1s go to level 3 pretty quickly because they understand the terminology they generally learned in university, and they can just ask it in their normal language, and a complicated threat hunting query comes back, and they can follow the bouncing ball. So it also accelerates the threat hunting, right? So as your behavioral, your static AI is detecting the attacks or the files, automatically and managing those for you with a high accurate true positive and a low false positive rate, it means you can do threat hunting because you've freed up some hours. So it accelerates your threat hunting. And then you can integrate that in your workflow. What does that mean? It means you can start to have playbooks or complicated playbooks based on generative AI. I use it to generate queries for me to plug in APIs, because sometimes that can take like half a day to work out how the API query for another system, and I just type it into generative AI and it prints me out a nice, complicated threat hunting query that I just connect to an associated system. And this is what it looks like. So this is what generative AI looks like. You just have a Google-style bar at the bottom, and then we give you, prompt engineering is not something we're all used to, and it's something we will have to learn. And if you don't understand the term, it means someone that is trained in how to work generative AI. It's called prompt engineering. So we're not all prompt engineers, so we've given you some examples. And these could be, are there any indicators of UNC C1373? That's an APT crew. I think that's fun. I think that's Wizard Spider. Or find evidence of that in my network, right? It will speed up your threat hunting queries. These are examples, right? TTPs. Get all user credentials or modification events, right? You might be looking for an insider, right? This might not be malicious, but it might be part of a playbook seeing if things have happened in your environment. Anomaly, these are my favorite. List all users that have access to pastebin, like websites in the last week, right? Just stuff that could be happening. Find PowerShell connections to IPs outside of the US or Australia or whatever, right? So you can just hunt, right? Threat hunting, you're hunting for things in your environment. So what's the outcome of this? So we ran generative AI threat ops challenges. So we had our best threat hunters, and we have some ex-military, Israeli, US, German threat hunters, and we put them against our standard SEs, and the standard SEs won the threat ops challenge. Obviously, the guys that have been doing it for years weren't allowed to use generative AI, and the SEs were, right? And it meant that the standard SE could outperform an attacker or a defender using these tools, right? So this actually gives you an edge against someone attacking you. If they're using generative AI and you're not, then they have the advantage. So whether you use us or someone else, I'd suggest you start looking into using generative AI for threat hunting. So what's next for the generative AI? So at the moment, we've launched a SecOps Assistant, so you can use that today, but generative AI or large language models have got some great things to look out for, things like configurations. If we've got an amazing configured customer, they still get incidents around what we've done. Generally because they misconfigured something or someone changed something for some project and they didn't put the configuration back. So we're starting to use large language models looking at configurations, right? So making sure that if you've got a list of 2,000 firewall rules, an LLM can look at that and tell you where the smoking gun is. Or, by the way, that rule doesn't work because there's an implicit allow above or deny, right? Firewall rules, we're generally bad at looking at that kind of data. So we're starting to train our large language models on configurations. And then auto investigators, right? So we're starting to automate this, right? And we're using data from SecOps analysts to infer responses that you may make. So what does that look like? So the model says the file is bad. The behavioral indicators indicate the file is bad. And you kind of go, okay, well, it's doing LSAS. I think it's pretty bad. And then the generative AI says, well, 76% of your peers also thought it was bad. So the machine said it was bad. You think it was bad. And now we're informing you that your peers are now thinking it's bad, right? So this is now, okay, now I'm pretty sure it's bad, right? Because that's the problem is the machine says it's bad and you need comfort that it's actually a true positive or a false positive. And you need that as quickly as you can, right? So you need multiple models to then really give you confidence that it is bad. And just having one model to do that, it can hallucinate, give you the wrong signal, and you're owned. If you do it through multiple models, then if they all say it's true, then, and you think it's true, then it's probably true. So that's the future of SOCs. They are going to look at data of your peers and then give you insight into what they think of those types of incidents. So the machine speed engagement, the generative AI difference. So it needs to be built on our leading AI security. We've been doing this since 2011, static AI. We've been training this with petabytes and petabytes of data. It's very fast, it's very performant. Luckily, it's just the nature of how it works. It's a maths model. Computers are really good at doing maths. We don't use signatures for the detections. We'll use signatures for attribution, kind of further down the chain, but we'll use static AI for file-based detections because it's really fast and performant, and customers need their computers to run and run the business, right? So and you need a performant data store, right? We've got a data lake or a SIEM if you like, or an next-gen SIEM, but whatever you use, it needs to be fast. And we've got some customers. I've spent some time in Korea and they've got some on-premise systems and they'll run a query and 7 hours later they'll get a response. I mean, it's just madness, right? You need fast response in minutes, especially if you're under attack and you've got thousands of incidents coming through. You can't run Ghidra fast enough. So up to 3 years of data retention if you're, if you need to do that, and then put the rest in cold storage if you need those logs. But having a storage facility that's XDR, OCSF ready is critical these days. And the third one, OCSF. Guided analysts to proactively hunt. That's incredibly important. We need to stop whack-a-moling. We need the machines to do more, and then we need to have the time to check whether it did the right thing. We have automated remediation and rollback, right? And people go, oh, well, the machine did something. Okay, well, once it's done a remediation and rollback, you can then check whether it did a good job. And if it didn't, then you can correct what was there. But it's done 98% of the work for you, right? So it actually speeds up how many incidents. And that's what people say, why are you different to other people? And it's like, we triage more incidents per hour than anyone else, just because of the way we've built the machine models. Right? And that's why large enterprises trust us with looking after their critical assets. And going beyond chatbots, integrating multiple models, right? We want to make sure we've got a lot of people, very big assets to trust us. So we want to make sure our models are behaving because, they put their trust in us. So we put multiple models there to make sure that we don't make mistakes. So you need to go beyond a single chatbot. And then you need to build on a mix of models, balancing responsiveness and capabilities. And then we need to check these models and make sure that they're performing, and if they're not, we can swap one out, right? Because we're using multiple models. All right, questions? Anyone have any? Is anyone heard of retrieval augmented generative AI? Because you should. I mean, just like not that you should. That's being rude, but like you should be asking, like vendors what type of AI they use. Because I do hear, every now and again, oh, we just updated the static AI and the LLM will work tomorrow. And it's like, that's just not how it works. So you need to understand static AI, behavioral AI, the types of LLMs, because you need to make sure that the products you're buying are fit for purpose and they will, last for the term of, whatever you bought it for.
We've got a couple of questions in the
awesome.
app. So is any data taken from client organizations to train the AI further? And if it is, what kind of data is it?
No, we don't train it on your, well, general LLMs may, but we don't. So our LLM is basically translating natural language into threat hunting queries. Once the threat hunting query comes back, then that will go and fetch the data like any threat hunting query, right? So that's not used to train your model. Because the LLM is just translating natural language into threat hunting queries. Once it comes back, we can do statistical analysis, which is anonymized, but it's not then used to train the model. It's just to inform you. We have different, like SentinelOne, for instance, we have data centers in Australia, the US, India, and in Germany and Frankfurt for GDPR. They're isolated. So that data stays in, if you have a sovereign data service, then it will stay in country. And we don't use that data to train other LLMs. We'll pull data from things like VirusTotal, right? And other open source services, right? So we don't train it on your incidents, we train it with the stuff out there.
Can AIs, even static AI, be inaccurate if the knowledge base or data from which they learn are poisoned? Is there anything you can do against your data poisoning attacks?
There's stuff you can do against it. Like the answer is yes, of course. If someone's poisoned the data store, then yes. That's the reason we use multiple models and multiple tests or checkpoints. If you say, give me all lol bins, the query will come back and it will have a list of executables. So you could check that if you wanted to, so you can manually check this. If you didn't want to use it, you'd have to write it yourself. So sometimes the queries come back and I check to see whether it's actually what I asked, because I can write the queries myself. And then I might tune it, right? So there's always a human interaction. You can do like fully automated, but that's just generally for companies that don't have the time or the money to have SOC analysts. So there's levels of automation you can put in there, but we have people to check these data stores. We'd bring data in from MITRE. MITRE TTP is not really something that would poison the data, but yeah, it's a good question and stuff we are ensuring we take seriously.
Are most of the solutions that are out there static AI? Because it seems to be a common buzzword amongst the vendor world.
It's hopefully static AI should be used. If you're using signatures, it's too old. I hope most of them are, but not many are really using static AI. There's a lot still doing signature-based detections, right? If they say, oh, that looks like Wizard Spider, it's generally an IOC, which is a signature, because you're attributing, right? So you must be using some sort of signature, unless you're doing post. But yeah, static AI should be used. Behavioral AI should back that up if it's allowed to run, and then you should be, adding things like large language models and retrieval augmented large language models on top of that.
Do we have any questions from the audience? All right. Please thank Wayne.
Thanks all.